Welcome to the Introduction to Object-Oriented Programming in Python. In this crash course, we will be exploring what is object-oriented programming, what are the four pillars of object-oriented programming. We will talk about, among others, inheritance, encapsulation, polymorphism, abstraction, and much more. The key concepts will be demonstrated in Visual Studio Code on simple examples. So yeah, without further ado, let's get started. And before we get started, I just want to mention that the presentation for the crash course is going to be available on my website. I just launched it. It's not ready yet. There's a lot of things I have to do. However, you can find my newest course over here. And if you join the newsletter, I will send you the link to this presentation. So if you want, just join the newsletter over here. And of course, the link to this page is in the description. So now let's talk about the contents of today's crash course. We will begin from asking what is actually object-oriented programming, and we will discover its four pillars. Then we will take a look at a simple code example, and we will talk about the basic definitions related to coding in the object-oriented programming way. We will next take a look at the constructor and destructor. We will talk about inheritance, class variables, class and static methods, the property decorator. Then we will have encapsulation and method overriding. We will then move to polymorphism and abstraction. And finally, we will take a look at the role of loops and the next steps. So what is exactly OOP? In simple terms, OOP stands for Object-Oriented Programming, and it's a style of programming that focuses on using objects. It's a way of organizing and structuring our code to model real-world entities as objects, which can have data, so known attributes, and behaviors, so known methods, which are associated with them. So now let's talk a little bit how this works in practice. On the left, we see a cat. On the right, we see a dog. So we can create two classes for a cat and a dog. And classes are blueprints that define the structure and behavior of objects. And we use them to create instances, in our case, of dogs and cats. So for example, we can create a cat setting some initial attributes. For example, the name would be Whiskers. The age would be, let's say, 5 years. The breed would be, I don't know, Maine Coon. Weight, let's say 7 kilo. And can swim. Swim is a Boolean. So let's say this cat doesn't know how to swim, and we can set this to false. Okay, so attributes describe the characteristics or properties of an object. So they are like variables that hold data specific to each instance of a given class, and they help to define the state of a particular object. And on the other hand, we have methods, and methods are functions that define the actions or behaviors that instances of a class can perform. And they sometimes relate to attributes. For example, if we add energy attribute over here, swimming can lower the energy level while sleeping can increase it, okay? So if this sounds confusing, just don't worry. We will explain everything in code on very simple examples very, very soon. So now let's move to the next slide. And the next slide is about four pillars of object-oriented programming. And this is not related to Python specific. However, I needed a nice illustration. So I figured out that object-oriented programming will be at the bottom. Then we will have four pillars. And I needed something at the top. That's why I placed Python. So we have inheritance, polymorphism, encapsulation, and abstraction. We will talk about each concept in this particular crash course. We will begin from inheritance, then we will talk about encapsulation, then we will have polymorphism, and at the end, we will talk about abstraction. But before we talk about inheritance, let's take a look at this very simple code example where we have only one general class called animal. So later we will create a class for the dog and for the cat. These classes will inherit from the animal class, but for now, as mentioned before, we have only one general animal class. So inside of this class, we have methods. The first one is the constructor method called init. This is a dunder method, and I'm not going to talk about dunder or magic methods in this crash course, but what you need to know is that this method is used to create instances of a given class. And we can see this in action over here where we are creating animal instances. So to the dog variable, we are assigning animal, and here we are passing body. So body is the name, okay? Then we have the dog, and the dog is the species. And the age is going to be 3. So to sum up, over here we have created a dog named Buddy at the age of 3 years. Below, we are creating a cat. Okay, so again, cat refers to the species, the name is Whiskers, and the age is 2. In each method, we see at the beginning self, and self is a reference to the instance of the class that the method is operating on, and it's allowing us to access its attributes and methods. Okay, so if we take a look at this it method over here, it takes in, of course, self, but then we are printing self name, the self species is eating. And if we take a look at the output for the dog, we have body, the dog is eating. So again, self refers to a given instance we are operating on. Here we called eat on the dog instance, so we can say that we made the dog eat. And here we used self to initialize attributes. And now it's time to be a little bit more precise in terms of basic definitions. So we have parameters, attributes, methods, and arguments. Those 5 definitions you will often hear in terms of coding in object-oriented programming. So let's begin with the attributes. Attributes are characteristics of an object. So in our case, we have name and the age for the student class example. Then we have the parameters. So these are the variables used in a function or method definitions to represent the values that will be passed to them when they are called. So we can see them in the init method. This is the name and the age. And over here we have the parameters of the add numbers function. And this is the A and B. So the parameters are kind of like placeholders, you can say. These aren't the actual values. These are just the variables or variable names, okay? And then we have arguments, and these are the actual values given to functions or methods when they are called. So over here, Alice, 20, these are the arguments. In our previous example, body, dog, 3, Whiskers, cat, 2, these are the arguments. Here we have the parameters, but here we have the arguments, right? And these are the attributes. All right, and then we have functions and methods, and this is pretty easy. Functions are blocks of code with specific tasks capable of taking parameters, while methods are functions linked to objects able to access their attributes. So a function becomes a method when it's inside of a class and it's able to access the attributes of an instance. After this slide, we will take a look at an example in Visual Studio Code. I just want to mention Destructor, since we talked about the constructor and we talked about the very basics of creating an instance of a class. So if we would like to remove an instance and add to it some special behavior, we can do it by overriding the del method. And this is another dunder method. So if we don't have it, we can delete the instances just like over here. But then if we would like to add some additional behavior to it, we would need to override the del method. And if we do it, we will see Buddy the dog is being deleted, or Whiskers the cat is being deleted. All right? So let's now take everything that we learned so far and use it in practice. So at Visual Studio Code, I have created a very simple car class, which is described by some attributes: brand, model, year, is running, and speed. And it has two methods, start and stop. So just to recap, over here we have the parameters, here we have the attributes, and now we are going to create our first instance where we are going to pass the arguments. So I'm going to create a myCar variable, and this is going to be equal car class, where we are going to pass as the brand Audi, as the model A4, and as the year 2021. So now we have my car, and we can start this car. So let's write my car start. And then I'm going to print my car dict. So we will have this instance of a car described in a dictionary. So I'm going to save this and I'm going to execute this code. So we have the 2021 Audi A4 is now running. The brand is Audi, model A4, year 2021. This running is now true, so the state has changed because initially it was false, okay? And the speed is 0. So we didn't include acceleration in this start method, but what I can do is to write self speed is equal to, let's say, 100. All right, I'm going to save this and run it one more time. And now we have the 2021 Audi A4 is now running, and we have brand Audi, model A4, year 2021 is running true, and the speed is 100 right now. So the state for the speed has changed as well. Okay, so for stopping, we can write self speed is equal to 0, and then we are changing the is running to false. So over here, let's write my car stop, and then let's print my car dict one more time. All right. So as you can see over here, we returned to the initial state. Is running is now false and the speed is 0. So now let's try to delete the object without the destructor. So I'm going to simply write del and then my car, and then I'm going to try to print my car dict. Okay, let's save this, let's run it, and as you can see, name my car is not defined. All right. But over here, we don't have any info that this instance of the car class has been in fact deleted. So what we can do is to add this destructor. And here we can print that, let's say, the self, maybe brand, or I'm just going to copy this code and place it over here just to save time. And then I'm going to change the ending has been removed. Now I'm going to save this and run it one more time. And now we have name my car is not defined again. However, we have this information that the 2021 Audi A4 has been removed. Now let's talk about inheritance, which is the first pillar of object-oriented programming. So whenever a class inherits from another class, it gets all the methods, including the constructor init method, from the superclass. If we take a look at our example, the superclass is the animal and the class inheriting from the animal is the dog. So if we want to inherit from a different class, we need to create the class, give it a name, open up the parentheses, and pass in the class name from which we want to inherit. So over here in the superclass, we have the init method, and we need to set up the species. In the dog class, we need to set up the name and the age. But since we are inheriting from the animal, we also need to set up the species. So we are calling the parent init method with super init, and we are passing as the species the dog. And this makes sense because we are referencing the dog class, so the dog is going to be fixed. If we would have a cat class, we would set this as cat. But then we have to also remember to set the name and the age. So as the name, we are setting this name, which is, sorry about this. Okay, we are back on track. We are setting body, and as the age, we are setting 3. All right. So this is a very simple example. It doesn't make maybe that much sense since the name and the age actually should be in the animal class, but this is just an illustration. Remember that inheritance should help us with keeping and fulfilling the dry principle. So don't repeat yourself. And if we would create the class for the cat, we would probably repeat ourselves because we would have to place in self name and self age inside of the init of the cat class. But again, this is just an illustration. It would make more sense to place the name and the age over here, and then in the init have only dog specific stuff, and the same for the cat. In the init, we would have some cat specific attributes. But again, this is just an illustration. So to understand how super works, let's move to the next slide. Over here, we made a little change. We moved the name to the init of the parent class. So right now, when we are calling in the dog class super init, we not only are setting the species, we also need to set the name. The species is fixed because if we are referring to a dog class, it will always be a dog, but the name can be different. So here we are passing this name to the super init. Okay. And in the dog class, we just need to set self as age. Okay. So the instantiation looks exactly the same as over here. All right. So the last thing that I want to show you is this test method. And over here we have overridden the test method. So we have overridden in our dog class the test method from the animal. But since we are calling super test, we are calling the test method from the animal class. And then we are printing our own logic related to the dog class. Okay, so first we get this is a test method in the animal class. And then below we should see self name is a self species and it's self age years old. All right. So hopefully inheritance and super is kind of understandable. let's take a look at how it works in practice. All right, so I'm back at Visual Studio Code. Over here, we have our car class from the previous example, from the previous file. And we want to inherit from the car inside of this electric car class. And then we want to create the electric car instance and call different methods. So first of all, let's inherit from the car. So we need to pass in car, okay? And then we need to add a constructor, okay? And we are going to set the brand, model, and the year. So we need to place in brand, model, and the year. But we also want to set the battery capacity. And this is for the electric car. And now what we are going to do is to call super init of this car, where we are going to reference the brand, model, and the year, but not the battery capacity. So let's write super init, and let's pass in, of course, with double underscores. And let's pass in the brand, the model, and the year. But the battery capacity, and I made a mistake over here, it should be battery capacity, will be set over here. So self battery capacity is equal to battery capacity, okay? So yeah, this is basically it. We can now maybe override the start and stop method. So let's write start. This takes in self. Here we will call super start. Start. Okay. And then here we will print electric engine starting. And let's do the same for stop. Here, let's reference the stop from the parent class by calling super stop. And then let's write print and then stopping. Stopping like this. Okay, we could also add our own methods, for example, charge, and this is going to take in self, and we are going to print charging. Okay, so now let's create an instance of the electric car. So I'm going to place electric car is equal to electric car. Let's say it's going to be Tesla. Let's say it's going to be Model S 2023. And the battery capacity, I don't know, I'm going to place 100. Okay, and now we want to call different methods. So let's write electric car start, electric car stop, and electric car charge. Let's save this and let's run it. Okay, so now we have the Tesla S is now running and electric engine starting. Electric engine is at the electric class level, but the 2023 Tesla is now running, comes from over here, okay, from the super class. And then we have the 2023 Tesla S has stopped. So this is again coming from over here, from the super class. And stopping comes from the electric car class. And then we have charging, and this is specific to the electric car. Before we dive into the next pillar of object-oriented programming, which is encapsulation in our case, let's talk about class variables, then class and static methods, and the property decorator. And yeah, let's start with the class variables because we are currently at the slide related to this topic. So we have a simple zoo class, and above the constructor method, we have the class variable as a representation for this example. Over here, we have total animals set to 0. So this variable keeps the track of total animals in the zoo class. So whenever we instantiate a zoo, like we did over here, Central Zoo and Safari Zoo, we add some animals. Over here, we are adding 2 animals to the zoo number 1, which is Central Zoo, and 3 animals to the Safari Zoo. So in the Central Zoo, we have 2 animals. In the Safari Zoo, we have 3 animals. If we display total animals, it will give us 5, okay? Because this doesn't track the object state, it tracks the class state, okay? This is very important. Over here, we have the state of the object. Here we have the state of the class. And we are incrementing the total animals over here by referencing the class name and then referencing the class variable and incrementing it by 1. So this is one way to do it. The other way we will learn on the next slide. But what you need to remember is that class variables represent the state of a class. Here we have the state of the object. And if we have 2 animals in Central Zoo, this is related to self animals. So the state of Central Zoo will have, if we take a look at the animals list, it will have lion and elephant. In the Safari Zoo, we will have, over here in the Safari Zoo animals list, we will have giraffe, tiger, and monkey. But all together, the total animals will be equal to 5. So now let's talk about the class and static methods. So again, we have our zoo class example, but it's extended with a class method and a static method. If we want to create a class method, we need to add a class method decorator, like over here. And then this doesn't take in self anymore, it takes in CLS as class. And here we are resetting total animals with CLS total animals is equal to 0. So this add animal method could be also transformed into a class method. We would write class method decorator at the top. And then over here, we wouldn't have self, but CLS. And here we would reference CLS total animals and increment it by 1. Okay, so a class method sticks to a class and can deal with things specific to the class. Okay, a static method, on the other hand, isn't tied to any particular class or object, and it's for tasks and don't need special class related information. So here with the static method, if we want to have a static method, we just add the static method decorator at the top. We then create this method. It doesn't take in self or CLS. It just takes in a parameter. Okay, so in our case, it's a day. So it's not related to a class or object. And then we return simply information true or false. True if we are dealing with a weekend, and false if we are dealing with a non-weekend day. Okay, so this is how we can use the class methods and static methods in action. Here we are using the class method to reset the total animals. So we are calling the class zoo reset total animals. And here we are using the static method. So we are calling zoo is weekend. We are passing the day. Okay. And then we are bringing this day to lower and comparing it to Saturday and Sunday. And if it's Saturday or Sunday, we are returning true. In other case, we are returning false. So here we have Sunday, this is true. And here we have Wednesday, and this is obviously false. Next on the list is the property decorator. And the property decorator lets us make a method look and work like an attribute. And to understand this, let's take a look at this very simple example. Inside of our animal class, we have a method age in human years. However, since we've added the property decorator at the top, we can now access the age in human years as it was an attribute and a method. If you take a look at this, you don't see any parentheses at the end. So we are not calling a method. We are actually accessing this age in human years as it was an attribute, just like with the name. So next on the list is the second pillar of object-oriented programming, which is encapsulation. And this is a concept in programming where we bundle the data and its functions together in a class, and the getters and setters are a part of this idea. They let us read or change the data in a safe manner. And this keeps our code tidy and makes sure that the data is managed properly. If it sounds confusing, let's break it down. Before we talk about this single underscore, double underscore, and what is name mangling, let's take a look at our zoo class example one more time. This time it's a little bit different. If we take a closer look, we can notice we have getters, so get name and get location, as well as setters, set name and set location. So as mentioned before, with encapsulation, we want to improve our code structure and prevent accidental errors or unauthorized changes from happening. So the set location might be a very good example, because let's say somebody would like to change the location directly from outside, and he or she would place in as the location some integer. So the location would be an integer. It wouldn't be a city name, it wouldn't be a string, it would be an integer. And this could break our code. With the set location, we are first checking if the instance is a string, and only then we are updating the new location. In other case, we are printing that the format of the location is invalid, and please provide a valid city name. So in the outside world, when we create an instance of a class, we should consider if we don't want to use the getters and the setters to get the attribute value and to set a new attribute value. And if we do want to do this, we have some options. The first one is using the single underscore like we did for the name. And this indicates that an attribute or method is meant to be considered protected within the class, suggesting that it shouldn't be accessed directly from outside the class. Then we have double underscore. This changes the name of an attribute or method. It's meant to be considered private, helping to prevent accidental clashes with names in other parts of the code. And this double underscore is related to this point and with a technique called name mangling, which modifies the name of an attribute by adding the class name as prefix, which helps prevent clashes in subclasses. And the syntax is underscore class name double underscore attribute. So for our case, it would be underscore zoo double underscore location. All right. So we will see how this works in practice in Visual Studio Code. But this is the one way to use getters and setters. And there's another one, a little bit more Pythonic, where we use the property decorator. So in our example over here, we have both name and location marked with a single underscore. And over here we had location marked with double underscore, but this doesn't matter. What matters is that whenever we use the property decorator like this will be our getter. So if we are doing a getter for the name, we are ignoring the underscore in front. This is going to be our method name for the getter and for the setter as well. And then we are returning for the getter self.name, just like over here. And for the setter, we are referencing this name over here. We are writing .setter, and then we simply create a new method with the same name, but it takes in the new name because it's a setter. So right now we are referencing self.name and we are assigning new name but calling title. This means if somebody has a word name, both of those words will be capitalized. Okay? So this is for the name, and the same situation is for the location. So we have a property with the location name, and we have a location setter, and then we have another location method, but this time, since this is a setter, we expect a new location, and we are checking if it's a string, and if it is, we are updating this new location as the location. All right, now let's see how encapsulation works in practice. So I'm going to do it in a traditional way, not the Pythonic way. As a challenge, you can try to convert this into the Pythonic way. So what I want to do is to get the name, get the age, and be able to set the age. So let's fill out these methods very quickly. So we have get name, so we need to return self underscore name. Return self underscore name. Perfect. We need to do the same thing for the age, so we want to return self underscore age. And here we want to set the age. So here we need to maybe do some additional checks. So let's check if the self age is an integer, okay? And let's also check if the self age is greater equal 0. And then we can write self age is equal to new age. Else, let's print age has to be an integer and has to be greater or equal 0. All right. So now let's create an instance of a person. So I'm going to create a variable Tom is equal to person. I'm going to pass the name as Tom, and then the age is going to be, let's say, 20. Now let's understand the name mangling. So what I'm going to do is to print, and I'm going to place Tom, and I'm going to display the attributes of this Tom object as a dictionary. I'm going to save this, run this, and we see name, Tom, and then we don't see double underscore age, we see underscore person and then double underscore age. So this is name mangling. So now if we write print, let's say, this is actually over here. This is the step that we should take in this section. So let's write print Tom dot name. We shouldn't do it like this. We should use the getter, but let's try this. And then print Tom dot double underscore age. Let's see what will happen. I'm going to save this and run it. And we have an error, but before we were actually able to get Tom. Okay, so this worked. We shouldn't use it this way, but this works. But whenever we try to access the age, we can't do this because we don't have any attribute like this. We would have to use it like over here. So now I'm going to save this and run it again. And this time it worked. So let's set the new age for Tom. Let's say he had a birthday yesterday. So let's write Tom set age 21. And yeah, let's run this. Of course, we need to print Tom dict or Tom get age. So I'm going to do it first with Tom dict. Let's run it. We have the person age 21, so it's updated. So now let's try to run it with print and then Tom. Actually, we don't need to print because the get, oh no, the get age returns just the self age, so we need to do it. Tom and then get age. Okay, let's run this, and we have 21. Okay, so yeah, let's try to set the age and name directly. So let's write Tom and then name is equal to Tom with 2 M's at the end, and Tom dot age is equal to 23. And then let's print Tom dict. Will this throw any errors or not? Let's find out. I'm going to run this. And as you can see, no errors. So the name was updated. And again, we shouldn't update the name like this. But if we do, it works. Then we have the person age as 21. And we have created a new attribute where we have age set to 23. All right, before we talk about polymorphism, let's catch a breath. Let's talk about method overriding. We've done this before. So what it is, it occurs when a subclass changes or adds to the behavior of a method it inherited from its parent class. And this allows the subclass to do things differently or add specific functionality while still using the same method name. So if you follow my Django tutorials on YouTube, you've probably seen how I override the save method from time to time. For example, to generate a slug for the class that inherits from models.model. So for example, if I have a post with a given title, I want to generate a slug, and I can achieve this by overriding the save method. And here we have an animal class which makes a sound, and this is some generic animal sound. Then we have a dog which inherits from animal, and this make sound method is overridden. We have woof woof. The cat, similar situation, inherits from animal, and the make sound is meow. So here we are creating instances, and then we are seeing the overriding in action. For the animal, it's going to be generic animal sound. For the dog, woof woof. For the cat, meow. So it's finally time to talk about polymorphism, and this is the third pillar of object-oriented programming. And polymorphism is like using different things in a similar way. It lets us treat different objects as if they were the same, so we can use them interchangeably. So right now, let's take a look at our example. I have removed inheritance. I have removed the animal class because On the next slide, we have abstraction. And this is a very closely related topic to polymorphism, and I want to avoid the confusion. So let's focus on what we have here. And we have two classes, cat and dog, and both have a make sound method. So here we have a function below those classes. We have a function which takes in an animal and calls this make sound method, okay, on the animal. And this is possible to do it with the use of polymorphism because our classes cat and dog has the same method. So we can create instances of different classes, and then we can call the animal sound function where we pass the cat and we pass the dog. So now let's take a look at how this will work in Visual Studio Code. All right, so I'm at Visual Studio Code. Here I have three classes that share the same method, and the method is attack. Okay, so what we want to do is to create instance of a warrior. We want to create an instance of an archer and also an instance of a mag. And then we want all those heroes, you can say, to attack. So I can create an instance hero 1 is equal to, and then let's instantiate the warrior. So let's give it a name, brave knight, something like this. Knight. How to spell this? E-N-I-G-T, something like this. If I made a spelling mistake, sorry. Okay, let's move on to the hero number 2. Here we will have the archer. Let's give it a name, maybe precise shooter. And hero 3 is going to be the mag. And I'm just going to call it fire starter. All right, so now we want to use polymorphism to perform the attacks. So what we can do is to create a heroes list. We can place in hero 1, hero 2, and hero 3. And then we can perform a for loop. So for hero in heroes, what we want to do is for the hero to attack. So let's write print hero attack. Right? So I'm going to save this and let's try it out. And we have brave knight swings their sword, precise shooter shoots an arrow, fire starter casts a fireball. All right, we are almost there. We still have abstraction and the use of loops to cover, and this is basically it. So first of all, let's talk about abstraction, and this is the fourth pillar of object-oriented programming. And abstraction is about defining a common base structure with shared attributes and methods, including potential abstract methods that must be overridden by a subclass. So over here we have, again, our example. This time we have the animal class, and the dog and the cat inherits from the animal class. And this animal class inherits from ABC and has an abstract method over here. So this is a common interface, you can say, for the dog and for the cat to implement in its own way. So if we use this abstract method decorator, we require the dog and the cat to make its own implementation of this make sound method. Okay, and this is abstraction. So let's see how the abstraction concept works in practice. All right, so I'm at Visual Studio Code, and right now we have a very similar example to the one we've seen in polymorphism, but the difference is that our warrior, archer, and mag inherits from the character class, and this character class inherits from ABC and has an abstract method, and this abstract method is attack. So the warrior, archer, and monk are required to provide their own implementation of this attack method. So let's start with creating instances of different characters. We did this before, so I'm just going to copy this, place it over here, and I'm going to save this, run this, nothing happens, perfect. And now what I'm going to do is to remove the attack from the map. So here I'm going to place pass, and I'm going to save this and run this one more time. And now I have an error. Can't instantiate abstract class mag with abstract method attack. If I remove this abstract method or comment it out and run this again, as you can see, no error anymore. Let's clear this and run it one more time. As you can see, no error. But since this is an abstract method, the implementation of the attack is required. So if I bring this back, everything is working. So this was a remove attack from mag, and now we can use polymorphism. So we can grab our heroes and place them over here in this section. Let's save this, and everything works as before. And finally, we have loops. So loops are extremely important in programming because they enable us to do the same thing over and over, such as making a game work or doing things with objects in object-oriented programming. They are really important because they help us make things happen again and again in a smart and organized way. The importance of loops you can see probably if you ever try to create a game using Python with the use of Pygame library, for instance. You will have a game loop that runs the entire game. Over here in this example, we have an animal, dog, and cat class, and we have a function to create animals, and we use this function in a while loop. So while we have true and not break it, while we not break this while loop, we can create new animals. So we have animal where we are assigning to it this create animal function. We are providing animal type, dog or cat, and we are providing the animal name. And then we are printing animal name says animal make sound. And then we are asked if we want to add another animal. And if the answer is different than yes, then this while loop breaks. If it is actually yes, we are creating a new animal. All right. So this is more or less presented on a very simple example how loops work and how important they are in object-oriented programming. Okay, so finally we have next steps. We can learn about the Dunder magic methods. We can learn different design patterns. And most important, we have to practice. Okay, so this was an introduction to object-oriented programming in Python. I hope you enjoyed this tutorial. I hope you learned something. If you did, please consider subscribing to the channel, and I hope to see you soon.